A marketing company has determined that the demand function for wireless headphones is given by this lowercase p, where p denotes the headphone's unit price in dollars and x denotes the quantity demanded. We just want to keep in mind that as we come up with answers for this company, that we're going to keep their x, the number of wireless headphones that we recommend that they make, between 0 and 30,000, since that's the domain that we're on here. First thing we're going to find is the revenue function, so just some good practice using our formulas. So revenue is always capital R of X, and it is X times P. X, the number of things you sell, times P, the price you sell them for, and then you need to remember to distribute. So for this company, R of X is going to be X times RP is negative 0.085X plus 900. So when we distribute x into both of these, we get a revenue function that is negative 0.085. X times x will give us x squared, plus 900 times x is 900x. So there's our revenue function. The next piece says find marginal revenue. Marginal means take the derivative. So we're going to take r prime of x. I'm going to make sure we label our functions. We're going to take the derivative, so we're going to bring down the power 2 times this negative 0.8085. So we're going to get negative 0.17x. Derivative of 900x is just going to be 900. So we have our revenue, our marginal revenue, and then it says that we want to maximize our revenue. A typical question that you would be asked from a company is, what can we do to maximize either our profit or our revenue, or maybe minimize cost? Either way, whether you're trying to find relative max or relative min, you have two steps. First step is going to be to find any critical numbers. That means taking the derivative and setting it equal to 0. And second step is to make a sign chart. Trying to find a max or min. We use our two steps. So our first step to maximizing revenue is to take the derivative of revenue and set it equal to 0. Find those critical numbers. So we already took the derivative of revenue. We said it was negative 0.17x plus 900. Now we're just going to set that equal to 0 to find any critical numbers for this function. This is nice because we just have an mx plus b. We have a linear function. So to solve it, we're just going to try to get x by itself. We don't have to factor because we don't have an x squared and another x or anything like that. So we're going to subtract 900 from both sides, and then we're going to divide both sides by negative 0.17. So x doesn't come out to be a nice whole number, but we want to know that we have to round to a whole number just because it is working with headphones, so we're not going to round to a decimal. We're going to say x is about 5,294 headphones. There's our critical number. Is this what we're automatically going to recommend that they make? Well, first we need to check that it's within our domain. It is. And second, we want to make sure that it's actually going to maximize our revenue. We know not every single critical number is going to give us a max. So we need to check if it is using a sign chart. So we're going to put 5,294 on our sign chart first. That's our special critical number. It makes the derivative 0. And then we want to test numbers to the left and to the right. So we want to plug into the derivative always. The sign of the derivative tells you whether you're increasing or decreasing. So if I plug in 0 to the derivative, we'd have negative 0.17 times 0, which is just 0, plus 900. So definitely going to get a positive number here. Positive derivative means the original function was increasing. So far that looks good. And then plugging in a number to the right of 5294, I'm going to stay within my domain and just plug in any number that I want to. It's a random test value. Maybe I'll plug in 6,000. Into the derivative, so I have negative 0.17 times 6,000, so I'm getting negative 1020 plus 900 is going to stay negative. So a negative derivative means it's decreasing. So I went from increasing to a 0 derivative at my critical number, so I get a soft peak there, to decreasing. So I do get a relative max. So I'm good with recommending they make 5,294 wireless headphones for this one. Of course, their next question is going to be what? Well, how much revenue are we going to actually make off of this? So right after we give them their recommended amount to make, we're going to tell them how much revenue they're going to make off of creating and selling those headphones. So our revenue function is what we're going to plug into. We don't want to plug into the derivative. Remember, if we did, we would get 0 because it's a critical number. So we want to take that 5,294 and plug it into the original revenue function. So I just grab my calculator and I would plug in R of 5,294 is going to be negative 0.085 times 5,294 squared plus 900 times 5,294. Plug into that original function we found in the first part of this problem. And so our output is going to be our relative max revenue. And so since this is money now, we don't have to round to the whole number, we can round to the second decimal place. So we're getting a huge amount of revenue. This is always a good thing. So we're getting $2,382,352.94 as their revenue, their income from those sales. So assuming they can sell all of those headphones, if they can sell 5,294, that is the sweet spot. They're going to maximize their revenue. So there's some practice using the revenue function, taking the derivative of it, maximizing it, and then seeing what the maximum would be. And then on the other hand, if we're given cost, we can see what's happening to their profit during this time. So this wireless headphones company has a total cost given below here. This capital C of X is our total cost found using some algebra. And we want to find the profit function. So we want to remember profit is always capital P. That lowercase p is the demand. So we want to call it capital P of X. And it is revenue minus cost. And you're going to have some distributing to do here most of the time. So for this one, capital P of X is going to be our revenue, which we found in part A. So I'm looking back. Our revenue was negative 0.085 x squared plus 900x. So we're going to take that revenue we found in the first part, negative 0.085 x squared plus 900x. And we're going to subtract the cost function. We're going to subtract 209x plus 170,000. Be super careful. If you set it up like this, you'll probably make a mistake. Make sure you put parentheses around your cost function. That way you subtract both. You don't want to end up with plus a huge number at the end of a profit function. Normally it's minus because if you sell 0 things, you are out some money. So let's distribute here. We have an x squared term. So we have negative 0.085 x squared, nothing to combine there. But then we have 900x and we have a minus 209x. So we want to combine those to just get 691x. And we want to remember this is not plus 170,000. We distribute that negative over to it. So we get minus 170,000, which makes sense. If I test plugging in 0 into here, they sell 0 of these headphones, they are out $170,000. They've invested a lot of money into this company, and so they're going to lose money if they sell 0. So the next part says find marginal profit. Remember, there's not a formula for marginal. Marginal means take the derivative, so label it P prime of X. Taking the derivative here, I'm going to bring down the power. So I'm going to get negative 0.17x. When I do negative 0.85 times 2, be careful you don't square it. You bring down the power and multiply. And then the derivative of 691x is just 691. Derivative of minus 170,000 is just going to be 0. And now the next step, what X value would maximize your profit and what would the maximum profit be? So we're back to trying to find a max of something. We have our same 2 steps. We're going to take the derivative and set it equal to 0 and make a sign chart. So we just did this with revenue. Now we're going to try to maximize profit and see if maybe they have the same critical number. So let's see what happens. We're going to take the derivative of profit and set it equal to 0. Well, we just found the derivative of profit is negative 0.17x plus 691. We'll set that equal to 0 and solve it like a linear function. So I'm going to subtract 691 from both sides. get that x by itself. So I have negative 0.17x equals negative 691. I'm going to divide by negative 0.17 to get that x by itself. And x is representing number of headphones. So I would say this is about 4,065 headphones they would need to produce to get this critical number. Produce and sell if they want to have profit off of it too. And we want to see, is this actually going to be a maximum? So we're going to check using a sign chart. So our second